Good afternoon, everybody. Today is Thursday, September 8th, 2022. I am back from extremely late lunch, and today we're going to be back working on the Exercism, and we are going to work on the Enum concept. So, Enums Enum is a very useful module. I'm saying plural. That's why it doesn't read right. Enum is a very useful module that provides a set of algorithms for working with enumerables. It offers sorting, filtering, grouping, counting, searching, finding, min-maxing values, and much more. In general, an enumerable is any data that can be iterated over, a collection. In Elixir, an enumerable is any data type that implements the enumerable protocol. The most common of those are list and maps. Many enum functions accept a function as an argument. For example, you can pass the function all ? A collection, in this case a list of integers, and then a function where you are evaluating each element of that list, and then it'll return true or false. The most common enum functions are map and reduce. Map, \2, allows you to replace every element in an enumerable with another element. The second argument of enum.map is a function that accepts the original element and returns its replacement. So this is basically how we typically transform, a list of some elements into a list of elements that are more applicable to your solution. The second one is reduce. Reduce allows you to reduce the whole enumerable to a single value. To achieve this, a special variable called an accumulator is used. The accumulator carries the intermediate state of the reduction between iterations. The second argument to reduce is the initial value of the accumulator. The third argument is a function that accepts an element and an accumulator and returns the new value of the accumulator. So yeah, reduce we typically use to figure out the single sum or result of processing a list. When using maps with enum functions, the map gets automatically converted to a list of two key value tuples. To transform it back up to a map, use the enum.into. This is a function that transforms an enumerable into a collectible. Any data structure implementing the collectible protocol. It can be thought of as the opposite of reduce. Enum also has an enum into 3, which is a variation that accepts a transformation function to be applied while transforming the enumerable into a collection. It's interesting. Mapping maps. Instead of using enum into or enum map 2 plus enum into to apply a transformation mapping to a map, we can also use a dedicated map.new function. It works exactly like enum.into in that it accepts an enumerable and a transformation function, but always returns a new map instead of letting us choose a collectible. All right, cool. So yeah, that's interesting. I mean, I use map and reduce all the time. I can't say that I use enum into that often, so this might be a fun exercise. So we're going to be working on boutique inventory. You are running an online fashion boutique. Your big annual sale is coming up, so you need to take stock of your inventory to make sure you are ready. A single item in the inventory is represented by a map, and the whole inventory is a list of such maps. So this inventory element here is a name, a price, and a quantity by size, which of itself is a map: small, medium, large, extra large. And then we got some functions. All right, cool. So we're going to download our example and we'll open it up in VS Code. So we'll have we've got our source file, we've got our test file, which I will collapse and make it all simple. And then we'll put the README down here. Then we'll hide source down there. I'm gonna make this a little bit bigger just to help with the readability during the video. But all right, cool. So number 1, let's say implement sort by price. It should take the inventory and return it sorted by item price ascending. So given this list of inventory, it should return 20, 50, 50, and 65. So we've got enum.sort, and so we're going to do 2. So it'll take inventory, and then it'll take a function. And this function will take the inventory element, and then we need to sort it. So I want to open up the documentation so we can kind of see what this is all about. So there's the sort, and then you're saying, for each, so the function that gets passed in is going to have 2 elements. That's why they have &1, &2. So let's do that. Let's use the shorthand version. So we'll do that. And so for element 1, we're going to compare the price to element 2's price, and then it'll do that for the entire collection, and it should work. Okay, so this is going to be, what did they want? They wanted ascending, so this is returning price. So left. Find test. So that big. All right, so this is sort by price. And then we need to see what it expected. It expected 33, 60, 60, and 65. Where did it get? It got 65. Okay, so we just need the opposite. Less than or equals. All right, that looks good. I'm actually gonna make that a little smaller. Sorry for that, but yeah, I feel like I need the space. All right, so that was the first one. Number 2, after sorting your inventory by price, you notice that you must have made a mistake when you were taking stock and forgot to fill out prices for a few items. Implement with missing price function. It should take the inventory and return a list of items that do not have price. So, not have price. I mean, I would use filter in this case, but they didn't explicitly teach us filter. Yeah, I mean, reduces it to a single value. Map allows you to replace every element with another element. That's not what we're doing. Mapping into maps. Instead of using map into an app, apply transformation map into a map. We can also use dedicated map. No, that's not what they did either. So, I mean, I'm gonna use filter. I wonder if the analyzer is going to yell at me for that, but filters returns only those elements for which functions returns a truthy value. So we want to look into the inventory, and we'll say for each inventory element, we're looking for price. So we'll say I.price not is no. Well, no, we'll say price is not null. Not equal no. With missing price. Does not work. I think we want reject. Yeah. What does this return? It should take the inventory and return a list of items that do not have prices. So we're going to reject all the ones that do have prices. Okay. Either one will work. I'll leave it as reject. Update names. Okay, number 3, update item names. You notice that some item names have a word that you don't like to use anymore. Now you need to update all those items with that word. Implement the update names function. It should take the inventory, the old word that you want to remove, and a new word that you want to use instead. It should return a list of items with the updated name. Okay, so that sounds like a map to me. So we're going to do enum.map. And this is going to take the inventory. And then it's going to take a function. Yeah, we'll just do that. And what we'll do is we'll say it should take the inventory, the old word that you want to remove instead. So this looks something like this. Update names. So given an empty list, it returns an empty list. Given bamboo with 1 O, returns bamboo with 2 O's. Okay. So then we'll say name, say I, name, string dot replace I dot name, and we'll say old word, new word. So this is making an assumption that name is always present, which I think we'll get away with for this one. I don't know if without, it's always tough dealing with maps because maps inherently aren't really a rigid structure. So I don't know if I really like making that assumption, but I think it'll be fine. Yeah, update names. All right, so we're just gonna loop through it, and then for each individual inventory element, we're gonna use this like shorthand map syntax, where basically we say, given this existing map, update this key with this new value. So that should look good. All right, cool. Number 4, increment the item's quantity. Some items were selling especially well, so you ordered more in all sizes. Implement increase quantity function. It should take a single item and a number, a single item and a number n, and return that item with the quantity for each size increased by n. Okay. So item is going to be a map that has what's this look? Quantity by size key. So we could just do this. T by size. And we're just gonna increment them all. What's a nice clean way to do this? I mean, one way would just be to say small. I'm just gonna do small, medium, large, XL. This is one way to do it. I don't know if this is really the prettiest way to do it, but it does work. So we're gonna say small, medium, large, extra large. And these are gonna be plus n, plus count. Put my cursor. Plus count. Increase quantity. Run test a cursor. One failure. Key S is not found. So let's see. So given quantity by size empty, it needs to... Oh, it'll just works for an empty quantity map. Why? That's... I don't like that at all. All right. Well, one way to do this is we can say do item, and we'll match on quantity by size empty map. Can you pattern match on that? I wonder. And then we don't care about the count. Can you do when can you guard against an empty map, I wonder? His list is number, map size. There you go. When map size of quantity equals 0. Item. Oh. Item. There you go. I don't really like this. I mean, this gets into the whole thing of like, you're dealing with maps and you're not working with particularly structured data. Like typically in a production environment, this is where like the map would have a type spec, and the type spec would be explicit to say that like quantity by size has to have values. And so like not having values there is a little sus to me, but that's fine. Okay, so let's move on to number, I don't know, what are we on? Number 5 already? Yeah, that was task 4. Oh, this is task 4 too. Do all these work? They all work. Okay. So number 5, total quantity. Calculate the item's total quantity. To know how much the space you need in your storage, you need to know how many of each item you have in total. Implement total quantity function. It should take a single item and return how many pieces you have in total in any size. Okay. So one way to do this is to use there's a map.values function that returns all values from a map. So you say given A1, B2, you'll just get a list of 1, 2, 4, which I really like. So let's do that. So let's say what do we want to call this? Quantity sizes. We'll just call it sizes equals item. Well, no, map.values, and the map we're going to pass in is item dot quantity by size. And so now sizes is just going to be a list of integers, and then we can just reduce it. Sorry, we're trying to use functions here. So reduce, it's going to take the element, then the function that takes the element in the accumulator. And we want the version that passes in the accumulator, so I think that's just 3. It's weird that I only get the docs for... Yeah, there you go. There's the docs for the 3. Okay. So we'll say sizes. The accumulator is going to start at 0, and then we'll pass in a function, and we'll just say is element the first one? I'm going to open it up just because 3. X accumulator. Okay, accumulator is gonna be the second element. Okay. Doesn't really matter, I guess, because it's gonna be that element plus the other element. All right, let's run test at cursor, and those look good. And now we'll run all of our tests, and they all look good. All right, cool. So, is there anything we want to fix or clean up? I think this looks pretty good. This is probably the most sus function implementation. I think we should probably use map because they the whole purpose of this is the whole purpose of this is to do the enum stuff. So let's say the quantity, we'll say new, or no, we'll just say quantity. Map dot, or no, enum, enum dot map. And so this is going to take in the item dot quantity by size, and yeah, I don't really like doing that inline, but that's now. And so for each one of these, it's going to do a function here. It's going to be the element. I want to do this separately. Just to make this more explicit. So for each size, we want to return so that's going to be this is going to be enum, so it's going to enum through each of these key value pairs. So instead of this, it's going to be the tuple, like they talked about in the explanation. Key value to transform it back into a map. Enum into enum map. Enum into or enum map plus enum into to apply a transformation mapping to a map. We can also dedicate a new map.new. Yeah, I want to try to use the stuff that they're teaching us. Creates a map from an enumerable via the given transformation function. So given that example, duplicate keys are removed. Creates a map from an enumerable. It's weird. Inserts the given enumerable into a collection. Note that passing in a non-empty list as collectible is deprecated if you're collecting. Inserts into according to the transformation. Yeah, this is definitely the part that I don't have as much experience with. When using maps with enum functions, Maps get automatically converted to a list of key value tuples. Okay. To transform it back to a map, use enum.into. Is a function that transforms an enumerable into a collectible. Any data structure. Okay. Instead of using into or instead of into 3 or with that to apply transformation, we also use dedicated apply transformation mapping to a map. We can use an enumerable and a transformation, but it always returns a new map instead of a It's weird to me that the example to this passes in a list. That's just a weird example. That makes sense to me. You're passing it a list of, key value tuples and returns a map. That's weird. I don't get that. I don't get that part. I mean, and then enum into. I get this. So enum.into given a map A1, B2 and a starter map of C3 for each key value tuple, return that. That makes sense. I mean, that's basically what we want. So we're going to say starting with quantity by size, and we'll start with an empty map. What we want is the value plus count. And then we're just going to return item, and we will substitute by size for quantity by size. And don't you like this? Oh, we gotta do item. We might not need this one. Let's see if this works. Cool, that looks like it works. So we'll delete that. I think I'm happy with that. All right, let's upload this. Submit lib to see if the internet robots do not like me, and they don't. Let's see here. What do they have to say? Use enum.sort by. Sort by. Oh, okay. I'm passing the. Okay. That makes sense. Enum.sort by. Let's try this out. Sort by. Ascending. Cool. I'm down with that. So we'll say inventory, and we'll do one.price, and it should be descending or ascending. Let's run the test. It's good. What other things was the analysis upset by? I think that was just one. Okay, let's upload iteration 2. It's pressing, and it's 1. So we got 1 here. Oh, this is when passing an existing function as an argument, make sure to capture it instead of creating a new anonymous function. I don't know if that's a problem. Prefer using captured notation. Discouraged creating a new anonymous function. I mean, does it say what line it's complaining about? I think so. I mean, it's creating where are we creating anonymous functions? We're creating an anonymous function here when we're saying does not equal nil. And we're creating it here. Creating it here, I feel like I like. Creating it here, you could probably get rid of it. I don't know. I wonder. With missing inventory. Alright, we'll try to do that. We'll try to make the thing happy. So instead of rejecting, I'm going to filter. And so for the function, I'm going to pass it is nil. And I'm going to say price. Okay. All right, let's see if I've won any friends. No, it still complains. So it must be unhappy about that one. It's like, I don't know. What's so wrong about creating an anonymous function? When passing an existing function as an argument, make sure to capture it instead of creating a new anonymous function. Exercism prevents more. Why are anonymous functions so bad? I'm going to take a picture. I'm going to ask in the chat room why. Why is that a problem? But for now, I'm going to publish our solution. All right, iteration 3 looks good. Oh, we were going to look at the community solutions. So let's see. This person. Oh, look at them. They're creating an anonymous function. Sort by price. Yeah. They don't have the parentheses there, but that's kind of optional. The formatter will probably push it one way or the other, but you don't need it. New name. Looks good. That looks good. Enum reduce. That looks good. Yeah, they're all pretty standard. Okay. All right, I'm going to publish my iteration and mark it as complete. And with that, I have learned enums. I have unlocked 4 new concepts and 37 new exercises. Holy moly. That was a lot of work. And my button for show more concepts is all the way at the bottom. So cool. So we have learned enums. That's unlocked a whole bunch of stuff, and we'll get into that next time. So if you have any questions or feedback, definitely let me know. I want to thank you all for watching, and have a nice day, and I'll see you next time. Bye-bye.